All right, y'all, welcome to FRQ number 6. If you have made it this far, then you are probably very tired, just like I am, of making these videos. But, work hard, play hard. So, number 6, functions f, g, and h are twice differentiable functions with g of 2 equals h of 2, which is equal to 4. They also tell us that the line y is equal to 4 plus 2/3 times x minus 2 is tangent to both the graph of g at x equals 2 and the graph of h at x equals 2. So first and foremost, they want us to find h prime of 2. Okay, so h prime is the derivative of h. So the derivative is equal to the slope. Well, they gave us a tangent line equation right here. Nice and convenient. And your tangent line equation is always that y minus y1 m x minus x1. So if you just move that 4 over, it's used to the same thing that we're used to. Well, right there's m, which is your slope. So what's h prime of 2 equal to? H prime of 2 is equal to 2/3. Look at that. That is the easiest point you are ever going to see on an AP exam. Now, granted, that also means everyone else is going to get it too. But hey, feel good about yourself. All right, B. Let a be the function given by a of x is equal to 3x cubed times h of x. Write an expression for a prime of x, and then find a prime of 2. Okay, so 3x cubed times h of x, that's a function times a function. Okay, so it's going to be our product rule for derivatives. So a prime is going to be original times derivative of the second. So 3x cubed times h prime cubed. Or sorry, not h prime cubed, just h prime of x. Plus derivative of the first. So that's 9x squared times the original. So h of x. So there's our a prime of x. Then I want to find a prime of 2. So a prime of 2 is equal to 3 times 2 cubed times h prime of 2 plus 9 times 2 squared times, don't know why you're not letting me write there, h of 2. And I'm going to move up so we can finish this one out. So 3 times 8 times h prime of 2, we already found that, 2/3, plus 9 times 4 times h of 2, which is 4. So 3 and 3 is going to cancel out, so that gives us 16 plus 4 times 4 is 36. 9 times 4 is 36. 4 times 36 is 144, which is equal to 160. All right, so far, this question is not too bad. Just derivatives. All right. C, the function h satisfies h of x is equal to x squared minus 4 over 1 minus f of x cubed. For x is not equal to 2, it is known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. Use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2. Show the work that leads to your answers. All right, so here's where this one probably starts to get a little bit messy. Okay, so part C, they're telling us that this limit can be found, and it can be found using L'Hopital's rule. Okay, so a couple things to consider first of all. So if we're using L'Hopital's rule, then what does that mean we have to get the first time when we plug into the limit? Well, we have to get that indeterminate form, that 0 over 0. Okay. The second thing is that if we know the limit can be found, then that means the limit exists. And if the limit exists, we also know that it's differentiable, which means it's continuous, which means the point exists, and the limit and the point are equal to each other. So what do we already know h of 2 to be? Well, we already know h of 2 to be 4. So we know that this limit has to equal 4. Okay, so just some extra conclusions to draw as we start working on this problem. Okay, so the first thing I want to find is I want to find f of x. Okay, f of x is going to be a little easier to find than f prime of x. I'm not going to get to f prime until I do my L'Hopital's rule. So I'm going to skip down here to the bottom. So I got some extra space. Okay, so I have the limit as not h approaches 2, as x approaches 2. the limit as x approaches 2 of x squared minus 4 over 1 minus f of x cubed. Well, for this to be true, we already know it's equal to 4, but we'll get to that later. We know that we can find this using L'Hopital's rule. So to find this using L'Hopital's rule, we have to have that indeterminate, that 0 over 0. So we know that the limit as x approaches 2 of x squared minus 4 has to equal 0. That's the first piece, the top. Okay, and that one holds pretty true. 2 squared minus 4 definitely equals 0. Okay, the other piece we know is that the limit as x approaches 2 of the bottom, that 1 minus f of x cubed, has to equal 0. So now I can use that to solve for what f of x has to be, or what f of 2 has to be, sorry. So plug in, so that gives us 1 minus f of 2 cubed is equal to 0, which means 1 is equal to f of 2 cubed. So we can take a cube root of both sides, which gives us 1 is equal to f of 2. So there we go. Found the first one, f of 2. Okay, now our second piece is we need to find f prime of 2. Now the only way we're going to get f prime of 2 is if we take the derivative, and the only way we can take the derivative is if we apply L'Hopital's. So by L'Hopital's, we can change this to be the limit as x approaches 2 of 2x over, not 1, sorry, 1's gone, of negative 3, because that 3 is going to come down, f of x, because the inside is going to stay the same, squared times f prime of x for the derivative of the inside. Okay, we talked about this earlier. We already know the limit's equal to 4. So what is this now going to be equal to? Because we did L'Hopital's rule, we know this all has to equal 4. Okay, so I can plug in 2, and then I can just start solving out for f prime. So we get 2 times 2 over negative 3 f of 2 squared times f prime of 2, and that's all equal to 4. So we get 4 over negative 3 times 1 squared times f prime of 2 is equal to 4. So this gives us negative 4 thirds is equal to 4 times f prime of 2. So I'm going to multiply that f prime of 2 over because I want to get it by itself, then divide the 4 back onto the other side, and we get negative 1/3 is equal to f prime of 2. All right, so this problem, if you know L'Hopital's well, is not too bad. You just have to use the first step, L'Hopital's equaling 0 over 0 to solve for f of 2, and then apply L'Hopital's, and knowing what the limit eventually has to equal, which is the same as the value of the point because it's continuous, and solve that out to get f prime of 2. All right, now this very last question, part D. All right. So part D, it is known that g of x is less than or equal to h of x for 1 is less than x, which is less than 3. Let k be a function satisfying g of x is less than or equal to k of x is less than or equal to h of x for 1 is less than x is less than 3. Is k continuous at x equals 2, and justify your answer. All right, so part D says by squeeze theorem, yes. You might have noticed we've never talked about squeeze theorem in AB because it's not supposed to be an AB topic. Okay, you're probably like, Mr. Arbone, why is there this extra theorem you just never told us about? Well, there's lots of theorems, but this one's dumb. I don't know why it's on the AB exam. I'm going to be real honest with you. If you got all 44 of the other points, I think this 45th point you will survive without. So squeeze theorem, it's dumb. Don't worry about it. All right, and this concludes Mr. Darbone's edition of walking through all the FRQs with you. Congrats on making it this far. You're amazing.